What if I told you there's enough energy inside an atom to power an entire city? It sounds impossible, but it's real. And understanding that power is exactly what nuclear physics is all about. From the sun that keeps Earth alive to the electricity powering your phone, nuclear physics is everywhere. Let's shrink down to the invisible world inside every atom and discover how the universe really works. Everything you can touch, see, or even breathe is made of atoms. Atoms are unbelievably small. Millions could fit across the tip of a needle, but inside each one is a tiny core that holds almost all of its mass. That tiny core is called the nucleus, and unlocking its secrets changed science forever. Every atom is built from just three tiny particles: protons, neutrons, and electrons. Protons carry a positive charge. Neutrons have no electrical charge at all. Electrons carry a negative charge and race around the nucleus at incredible speeds. Most of chemistry happens because of electrons. But nuclear physics looks much deeper, straight into the heart of the atom. This tiny nucleus contains almost all of the atom's mass. It also stores an incredible amount of energy, but here's the question that puzzled scientists for years. If protons repel each other, why doesn't the nucleus explode apart? The answer is something incredibly powerful called the strong nuclear force. It's one of the four fundamental forces that shape our universe, and at extremely short distances, it's the strongest force known in nature. Think of it as an incredibly powerful glue holding the nucleus together. Without it, every atom in the universe would instantly fall apart. That means no planets, no stars, and no life. Luckily, this invisible force keeps every atom stable, but not every atomic nucleus stays stable forever. Some atomic nuclei are naturally unstable. Over time, they release energy to become more stable. Scientists call this process radioactivity. Radioactivity isn't science fiction. It's a completely natural process happening all around us. There are three main types of radioactive decay. First comes alpha decay. The nucleus ejects two protons and two neutrons together as a single particle. Next is beta decay. During beta decay, a neutron transforms into a proton, or a proton transforms into a neutron. At the same time, a tiny particle called an electron or a positron is released. The third type is called gamma decay. Unlike alpha or beta decay, no particles leave the nucleus. Instead, the nucleus releases a burst of high-energy gamma radiation. The nucleus keeps the same number of protons and neutrons. It simply loses excess energy. Radioactivity may sound dangerous, but it also improves millions of lives every single day. Doctors use radioactive materials to diagnose diseases and treat cancer. Smoke detectors even use tiny amounts of radioactive material to help keep your family safe. Scientists also use radioactivity to discover the age of ancient fossils and artifacts. But nuclear physics can do something even more extraordinary. It can unlock one of the most powerful energy sources ever discovered. This process is called nuclear fission. It begins when a heavy atom, like uranium, absorbs a single neutron. That tiny impact makes the nucleus unstable. Then it splits into two smaller nuclei. That single split releases an enormous amount of energy. It also releases several fast-moving neutrons. Those neutrons can strike other uranium atoms nearby. Each collision triggers another fission reaction. This self-sustaining process is known as a chain reaction. When carefully controlled, that chain reaction can generate electricity for millions of homes. But if that chain reaction isn't controlled, the results can be catastrophic. That's the basic scientific principle behind nuclear weapons. The same science can either power cities or cause unimaginable destruction. It all depends on how humans choose to use that energy. Now let's explore an even more powerful process called nuclear fusion. Fusion is the opposite of fission. Instead of breaking atoms apart, fusion combines light atomic nuclei into a larger one. That tiny merger releases an incredible amount of energy. In fact, fusion produces even more energy than fission. Every second, this incredible process powers our sun. Every star you see in the night sky shines because of nuclear fusion. Without fusion, the sun would go dark and life on Earth wouldn't exist. That's why scientists around the world are working to recreate fusion here on Earth. If successful, fusion could provide nearly unlimited clean energy. It would produce very little long-lived radioactive waste and no greenhouse gas emissions during operation. Commercial fusion power is still under development, but the progress is incredibly exciting. Nuclear physics physics already helps generate electricity, diagnose diseases, explore space, and reveal the history of our universe. From the smallest particles to the largest galaxies, it connects everything in the cosmos. The more we understand the atom, the more we understand our universe and ourselves. If you enjoyed this journey into nuclear physics, hit the like button, subscribe for more incredible science stories, and I'll see you in the next video.